Hello everyone, welcome to session 5 of graph theory. In this session we study about walks, paths and circuits. Definition of walks. Definition. A walk is defined as a finite alternating sequence of vertices and edges beginning and ending with vertices such that each edge is incident with the vertices preceding and following it. No edge appears more than once in a walk. A vertex, however, may appear more than once in a walk. Open and closed walks. Definition. A walk that begins and ends at the same vertex is called a closed walk. A walk that is not closed, that means the terminal vertices are distinct, is called an open walk. Here is a graph with 5 vertices, one self-flow C is there and remainings are edges, that is A, B, this C is self-flow D, E, F, G, H and vertices V1, V2, V3, V4, V5. Now we construct an open walk. CV1 start from the vertex V1, then A is the edge, it goes to V2, then B is the edge which goes to V3 as the end vertex. Now V3 to C, again it comes to V3, next it goes to V4, edge is D, V4 to V2 connected by edge E. Next V2 to V5 connected by the edge F. So this is an open walk which starts from V1 and ends with the vertex V5. So here V1 and V5 are distinct vertices, distinct end vertices or terminal vertices, and therefore this is a walk. Here see the vertices are not all distinct. Here see V3 repeats. So in a walk, vertex can appear more than once, but edges see different A, B, C, D, E, F. So walk has vertex can appear more than once, but edges are all distinct. Now we have an example of a closed walk. See, V1 starts from V1, A, V2, then it goes to B, V3 here, and then G to V1. See here, starts from V1 and ends from V1. So vertex V1, here end vertex V1. So two end vertices are the same. So this is a closed walk. See this triangle, it is a closed walk. Also we have V3C, V3. That is a self-flow is always a closed walk. Here see V3B, V2E, V4, D, V3. This is also a closed walk triangle. Also we have V3B, V2, F, V5, H, V4, D, V3. That is like rectangle. So all are closed walks because the end vertices are same. Paths definition. An open walk in which no vertex appears more than once is called a path. Here is the same graph with 5 vertices and here V1, A, V2, B, V3, D, V4 is a path because all the vertices V1, V2, V3, V4 are distinct in this walk. This is a walk with no vertex appear more than once and it is open walk, therefore it is a path. Now the walk that is V1, A, V2, B, V3, CV3, DV4, EV2, FV5 is not a path, but it is an open walk. Here V3 appears more than once, therefore this is an open walk, but it is not a path. Path means all the vertices in the open walk will be distinct. Note, the set of vertices and edges constituting a given walk in a graph G is clearly a subgraph of G. So this walk is, that is V1, EV2, BV3, CV3, DV4, EV2, FV5. See, like this. This is a subgraph of the given graph G. Length of a path. Definition: the number of edges in a path is called the length of that path. Note 1. A self-loop can be included in a walk but not in a path because self-loop has the same end vertices. The terminal vertices of a path are of degree 1 and the rest of the vertices called intermediate vertices are of degree 2 in a path. An edge which is not a self-loop is a path of length 1. That is, every edge is a path of length 1. Circuits definition: a closed walk in which no vertex appears more than once is called a circuit, or a closed path is a circuit. That is, a path with the end vertices are same, that is closed path. So we have the example here. This is the hexagon with the 6 vertices. Now we observe that each vertex is of degree 2. That is, each vertex is incident with 2 edges. And here is another example of a closed path, that is circuit, that is self-loop. Self-loop is always a circuit, and clearly every vertex of circuit is of degree 2. Now, third note, walks, paths and circuit etc. are of a graph, also subgraphs. Problem: list any 3 paths from vertex A to vertex R and 3 circuits in the following graph. Here see the graph with 5 vertices A, B, P, Q, R and edges E1, E2, E3, E4, E5 and E6, 6 edges. Now we have to form 3 paths from A to vertex R. Solution: paths are: first one, vertex A, edge E2, vertex A, edge E2, vertex P, edge E5, vertex Q, edge E6, vertex R. So A, E2, P, E5, Q, R, E6, R is a path. Next, second one, A, E1, B, E4, R. So A to R is a path. Third one, A, E1, B, E3, Q, E6, R. So this is also a path. Here we see that all the vertices, here A, P, Q, R, here A, B, R, here A, B, Q, R, all the vertices are distinct. Now circuits. First circuit, A, E1, B, E3, Q, E5, P, E2, A. So here see, this is a closed path. End vertices are same. Intermediate vertices B and Q and P are distinct. Second circuit, A, E2, P, E5, Q, E6, R, E4, B, E1, A. So this rectangle is a circuit. Here end vertices A and A are same. Intermediate vertices P, Q, R, B are distinct. Third circuit, B, E3, Q, E6, R, E4, B. This is a triangle. See, this is also a closed path, so it is a circuit. Here we see end vertices are same, all the intermediate vertices here Q and R are distinct. Thank you for watching this video. Thank you all.